Good evening, everyone. We'll be waiting for 5 more minutes, okay, so that others will also join. Okay, so I think we can start now. So can anyone tell me my voice is audible?
Yes, sir.
Okay, okay. Mm. Could you share the screen? Mhm. Okay, so you all can see the screen? Yes?
Yes.
Okay. See, basically today we'll be discussing kinematics and dynamics part, that is laws of motion friction. So before moving ahead, let me just give you a brief about kinematics, or you can say just it like a revision. Okay. So basically what I'll do is I'll introduce the topic, then we'll go ahead with the problem solving. Okay. Can anyone tell me what is the basic definition of kinematics? What we generally do in kinematics? Anyone? So what we all
It's a
have?
study of motion.
Yeah, it's a study of motion without going into details about the cause of motion. Okay, so study of motion is correct. Study of motion. Okay, second point is we don't need the cause of motion. Cause of motion. Okay, now next, if you remember, we started this topic with displacement. Displacement is what? In layman term, you can say that if you are at this position right now, okay, now you have moved to some other position after some time, then it is RF. These are the position vectors. Okay, so the displacement will be represented as this vector, correct? Okay, and we know that displacement mod, that is the magnitude, is always less than or equal to the distance. Okay, what next? Average velocity. What was average velocity? Total displacement by total time. That is RF minus RI is your total displacement, and TF minus TI is total time. What about instantaneous velocity? It is when this time interval delta t is tending to 0, that means the time interval is very small, then we can write instantaneous velocity like this, which is also written as dr by dt. Similarly, acceleration, it is dv by dt, or you can say d square r by dt, correct? So we have introduced the basic terms. Next, what we have seen in class 11 was equation of motion, correct? Where we have seen v vector is equal to u plus a t. Displacement vector is equal to initial velocity into time plus half acceleration t square. See, I'm writing this formula in terms of vector, so you can use it in any situation. V square minus u square is equal to 2a dot s. Okay. In most of the cases, for 3D application, these two formulas are used, and this is generally used in one-dimensional problem. Okay. One more important thing we have seen is s nth, that is displacement in nth second. See, right now we don't need to know the derivation of all these things. We just need to memorize these formulas so that you can use it properly in your exams. So if you remember, it is initial velocity a by 2 to n minus 1. This formula is important. Sometimes questions can be asked directly. Okay. And then we have seen about g, that is acceleration due to gravity. Okay, which is, if you will read in you have already read actually in gravitation, which is this 9.8 meter per second square. Sometimes we use at 9 as 10 meter per second square. Correct? Now these are like basics. Afterwards, one of the most important thing in kinematics where some good questions can be asked is graphs. You should be good at graphs and what are all the basic understanding. Okay, so let's see some types of graph first. Displacement versus time graph. See, I'm going a bit fast because I'm just revising the things. I hope that you all are getting it. Okay, if there is any doubt, please let me know. So this is xt graph, xt graph. Now you have to give me some answers based on these graphs. Okay, this is VA, VB. This is the very simple graph. The slope represents the magnitude of sorry, velocity. So more is the slope, more is the velocity. Then VA, VB. So position is same with respect to time. Okay. Now tell me about this. If this is your graph, can you tell me the nature of the graph? Because these two are simplest one. Okay. So can you tell me anything about the third one?
So the body has an accelerated motion.
Basically, the body is decelerating, or you can say retarding away from the origin, because you can see the slope here is decreasing. That means velocity is decreasing. That means it is a deceleration. Okay, so you can write deceleration away from origin. Okay, now let's see some other types also. Let's say this is x t. Now the graph is like this. What do you think? What does it represents? In this case, we can see that the position, that is x, is the body is going away from the origin because we are going in this direction. Also, the slope was decreasing, so it was a case of deceleration. But what about in this case?
So it is going the other direction.
It is going toward the origin or away from the origin?
Towards.
Yeah, correct. Because you can see it is going closer, that is, it is going in this direction. Initially, it was here, okay, that is far away from origin. Now it is going toward the origin, but still you can see the slope is decreasing, so velocity is decreasing. So you can say decelerating or deacceleration toward origin. Let's see one more type. See, these are like a question for you. This is not a theory. If you know these things in K-CET, you can easily solve graph problems. Okay. What about this? You can see that yeah, please tell.
Accelerating.
Accelerating because slope is increasing continuously. Correct? and the position is also going away from the origin. So you can say acceleration away from origin. Okay, one last type. Okay, like this. What about this? Here you can see initially the slope was 0. That means 0 velocity. So slope is increasing but in negative direction. Away from the origin is the positive direction. Towards the origin is negative direction. So basically this is a acceleration towards origin. Acceleration towards origin. Okay, clear? And in case of velocity time graph, there are basically 4 simple graphs. Okay, VT graph, VT graph, and VT graph. So first graph is like this. Second graph is like this. Third graph is like this. Fourth graph is like this. So can we say anything about the behavior of the graph one by one? First one is the slope of the graph is positive and it is constant. So acceleration is constant, and with time velocity is increasing. That means it is in positive direction. So you can say acceleration in positive direction. Second one is the slope is negative, okay, and with time velocity is decreasing. So you can say retardation in positive x direction. When you are saying positive x and retardation means opposite of positive x, that is negative x. About third, what about third? Velocity is increasing with time, but in negative direction. So you can say the acceleration in negative direction. Okay. Fourth one, velocity is decreasing because it is going like this. Okay. So you can say retardation in negative direction. Retardation in negative direction. Okay. Now, what we have seen after this was, I think, relative motion, if you remember. Okay. So do remember this basic formula and the notation also, that what does it mean? Then every problem of relative motion can be taken care easily. So what does it mean? It is velocity of A with respect to B. That means this is where the observer is located. And from here we are looking at the velocity of A. Correct? Similarly, acceleration formula AB is equal to acceleration A minus acceleration B. So what we can say is acceleration of A observed from B. Okay. And whenever you are dealing with relative problem, just remember this thing that let's say two objects are moving, and let's say one object is moving in some car and you are also moving and you are the observer. So what you can do is, since you are the observer, so your velocity make it zero and transfer your velocity to the observed but in opposite direction. That will always work. Okay. Next, since we have seen equation of motion also, but if let's say you want to use equation of motion in relative cases, then also you can use it. That is, v relative is equal to u relative into time plus a relative, sorry, this is into time, v equal to u plus at. Similarly, you can use s relative equal to u relative into time plus half a relative times t square, like that. Okay, so you can use this also. Next, we have seen about projectile motion. See why I'm writing all these important things, that at least you should not miss these basic concepts. Or if you, let's say, by heart these basic things, you can easily solve good number of questions in K-CET from this topic. So what was the formula of time of flight? Anyone? Anyone? It was 2u sine theta by g, r u square sine 2 theta by g. Sometime it is also written as 2ux, that is x component, and y component by g. Okay. Height is u square sine square theta by 2g. Okay. Clear? Now we have seen after this was projectile motion on inclined plane. Yes. Projectile motion on an inclined plane. See, whenever you are using the formula based on projectile motion of inclined plane, do check the standard format. If it is matching, then you can use the formula. But if let's say there are some changes, go with basic. Okay. Like let's say this is a inclined plane. Please respond in between. Otherwise, I won't be able to know that you guys are hearing me or not. Okay. So my voice is clear to everyone.
Yes, sir.
Okay. So let's say this is the inclined plane and the angle of inclination is alpha, and we have thrown an object with velocity u, and this angle is given as theta. So we can see here that the velocity, if you want to break it into components, will be ux, which is equal to u cos theta, and this one is ui, which is u sin theta. Now we have changed the coordinates according to the inclined plane. So we have to see the gravitation acceleration also. That means the g is in this direction. If you want to break in according to the chosen Cartesian coordinate, you have to say that this will be g sine alpha. This will be g cos alpha. Okay, correct. So time period in this case is 2u sine theta by g cos alpha. So initially we have seen that the formula in normal case was 2u sine theta by g. Okay, because that theta was with the horizontal. Here this theta is with the incline. So you need to keep this in mind. And why this g cos alpha? Because g cos alpha is acting in this direction. And just like In normal case, G was acting in downward direction. Let's say this is theta, this is U. So in this direction, G was acting. Now this G got converted into G cos alpha. Okay. If you want, you can remember this formula, but I'll suggest in most of the question, try to first check if it is matching with the standard format or not. Because in projectile motion, most of the things can be solved using basics. Like when you say that you are throwing an object with certain velocity at certain angle, you need to first break it into its components. Then you need to look for the acceleration part. Okay. If these two things you know, with the help of time, you can write any equation. Okay. From equation of motion in one dimension. Accordingly, you can solve number of problems. Okay. I think we have discussed enough. We can start with the problem solving. Okay. Okay. Let's see this first question. Okay. What should be the answer for this question?
So C.
Exactly. So if this is the point where we are talking about, one force will be the gravitational force, and since there is a air resistance, and at that instant the velocity is in this direction, correct, and the friction force will be exactly opposite to the direction of velocity, so our answer will be this.
So do you want us to answer in the chat, or do you want us to like say the answers out?
What you said, please
Do you
come
want
again.
us to answer in the chat, or do you want us to say the answers out?
See, if you want, you can say the answer also, no problem. It's better you say the option number. Okay. Those who are getting it, you can just say the options. Okay, this is the correct answer or not. Okay. Let's see next question. Yeah, this question. How we can proceed with this question? Basically, at the top point, we know you have to assume that some velocity v is there. Then that velocity you have, then you have to use the projectile.
So is the answer A?
Yes, answer is A. Okay, everyone got the answer?
So can you solve it?
Yeah. Basically, let's say and a body is just revolving in a vertical circle of radius r with a uniform speed, let's say v, and the string breaks when the body is at maximum height. And at this point, the direction, if you are assuming the circular motion in this direction, then the direction of velocity will be this, correct? And if the string is broken, that means it will go with this velocity in negative x-axis, and they are asking the horizontal distance covered by the body. So since there is nothing else is given, you can take this as your reference level. That means what is the distance covered? Basically, this is the distance they are asking, correct? Now we know that S is equal to, let's say you are talking about y-axis. There is no initial velocity, but there is acceleration. We can take it as 10 meter per second square. Okay. So when it will reach the ground, can you say that this ball must have traveled a distance of 2r? Okay, so we can use this formula S equal to ut plus half at square. That is S is equal to u is 0, so 0 plus half into 10 into t square. Correct? Where S is nothing but 2r is equal to half into 10 into t square. Or if you want to keep it like g only, so you can take as g also, because later on it will get cancelled. Okay, so what is t square we are getting? Let me keep it as this only. So t square is 4r by g. Correct? Now, we don't know anything about the velocity, because we will be needing velocity, this part, because in this direction, acceleration is 0 and it is having initial velocity as v. So the distance it will travel in this time, that is t is equal to root under 4r by g. The distance it will travel in this time is nothing but v into this time. So we want to find this v. How we can find it? So if you look carefully at this point, downward force is mg, and it must be balanced at just before the braking. It must be balanced by a centrifugal force, which is mv square by r. So you can say that mg is equal to mv square by r. So from here you will get v equal to root gr. If you put this here and this value also, you will get x as 2r.
Yes, sir.
Okay, I hope each of you have understood. Let's see next question. Okay, yeah, try this one. Mhm. Okay, now I have opened another window, so you can, if you want, you can drop the answer in the chat box also. This is a good question. At least you can give 1 or 2 minutes. See if you can solve this. So in this question, they are saying is a particle is moving in a circle of radius r in such a way that at any instant, normal and tangential component of the acceleration are equal. So initial speed is given v naught. Time taken to complete one first revolution is. Okay. So what they are saying is normal acceleration, we all know it is v square by r, and tangential acceleration is dv by dt. Correct? Now, according to the question, tangential acceleration and normal acceleration are equal. So you can say that dv by dt is equal to v square by r. Okay. C. Option C you are saying? No, I don't think so. Yeah, option B is the correct one. Good. Okay, let's see the solution quickly. So we'll separate the variable here, dv by v square, which is r dt. Now we'll integrate it. Okay, r is a constant, so outside the integration sign, 0 to t. Initial velocity was v naught, final is v. So from here, what we are getting is, let me write the final value itself, v naught r by r minus v naught t. This is the velocity we are getting. Now we need time. So we have to use something else also. That is, we know v equal to ds by dt. And we know we just found v as v naught r by r minus v naught t. So from here, you can just separate the variables, that ds is equal to v naught r minus v naught t, integrating it from 0 to 1 time period. Now look at this carefully, that since they are asking one time period, so we are putting it as one time period from 0 to how much? 2 by r. Okay. So if you do the integration properly, what you will get is t equal to r by v naught 1 minus e to the power minus 2 pi. This will be the answer. Okay, I just want to save some time. That's why I'm just skipping a bit of steps. So if you want, you can solve it by yourself also, so that it will be good for you for practice also. Okay, any doubt in this question, or do you want me to explain the integration part? No? Okay, let's see the next one. Okay, see this question. So the question is saying two particles A and B are projected with same speed. Okay, same speed. So the ratio of their maximum height reaches is 3:1. This is a given condition. Now they are doubling the speed of A without altering any other parameters. So finally, what will be the ratio of the horizontal range attained by A and B? So after the change of speed, we need to find the ratio of horizontal ranges for A and B. Let me tell you the formula. We just seen that h is equal to u square sine square theta by 2g. And according to question, HA by HB is already given to you, which is 3 by 1. And you can see here that u is same speed. So if you do the division, u square by 2g will get cancelled. What left will be just theta part. So you can write sine square theta for A, sine square theta for B. Okay, so you can see clearly that sine theta A by sine theta B, what we are getting is root 3. Now here at this point, we have to be a bit smart, that under which circumstances and which standard angles this situation is possible. If you look carefully, if theta A is equal to 60 degree and theta B is equal to 30 degree, then you'll get the same thing, because it is root 3 by 2 divided by 1 by 2. So 1 by 2 will get cancelled. What left is root 3. So you can basically we got what is theta A and what is theta B. Now we can easily find the range ratio. So range formula is what? Range, we know it is u square sine 2 theta by g. Now the speed of A is doubled. That means, let's assume, okay, when I said the answer D as 3:2. No, I don't think so. Please check the answer. Okay, So for RB, let's say that the velocity of B is u only. So u square sine 2 theta, 2 into 30 degree, correct? Divided by G. At the same instant, RA will be what? Now velocity is doubled. So you have to use 2u whole square. Sine of angle how much? 2 into 60 degree divided by G. Correct? Let's see what are these value coming as. This is u square sine 60, so root 3 by 2G. This is coming as 2u square. So 4, but 1 by 2 will cancel each other. So 2u square root 3 by G. We all know sine 120 is also positive, correct? So I think we got the answer, because if you see RA by RB is nothing but 4 is to 1, because 2 by 1 by 2 is 4. This would be the answer. Correct? Any doubt in this? Okay, let's see the next one. Try this one. See, I'm going a bit faster because I want to touch different types of questions. So please manage the pace. So basically what the question is saying is two bodies are projected from ground with equal speed 20 meter per second from same position in the same vertical plane to have a equal range but different angles above the horizontal. Okay, so what we know about range is 2ux uy by g. In general cases, ux is what? U, sorry, it is generally u cos theta. Uy is u sine theta. So if you look carefully in the two situation, if you want the range to be same, B, someone is saying B. So it is, yeah, B is correct. B is correct. Very good. So by seeing the question itself, I think you might have seen that theta 1 is 30 degree, theta 2 is 60 degree, because they are complementary angles. Okay, because sine 30 is 1 by 2, cos 60 is 1 by 2. So you can say that h1 is equal to u square sine square 30, because speed was same, so you can just write u. For h2 it is u square sine square 60 by 2g. Okay, now in the question they are saying that where, yeah, in the vertical range different, if one of the angle is 30, the sum of their maximum height is, so we need to find h1 plus h2, which is u square by 2g sine square 30 plus sine square 60. Okay, if you look carefully, this will become 1. So it is u square by 2g. Put the value of u, which is 2400, divided by 2, 200 divided by 10, which is 20 meter. Should be the answer. Clear? Let's move ahead. Okay, see this question. Okay, this is also interesting question, but easy one. Please try. Okay, let's see.
So just a minute to solve it. And
What?
so can you give us a minute to solve it?
Okay, 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 no problem. So some of you are saying A. Yeah, this is correct. A is correct answer. Now let's see the solution part. So in this question, the time relation is given to you. Okay, this is this alpha. Okay, keep it alpha. So in the answer, if you look carefully, there is a velocity part. So somehow we have to introduce the velocity part. How we can do it is differentiate this with dx. So 2 alpha x plus beta. We know dx by dt is velocity. So that means v must be equal to 1 by 2 alpha x plus beta, which is 2 alpha x plus beta to the power minus 1. Now, we also know that acceleration is equal to v dv by dx. Correct? Why we are, see, this question is like a maths problem. So you have to look at the answer, then try to connect from the initial given conditions to the final answer. So we can see no such answers is given in the option. So we have to move ahead a bit. Okay. And you can also see v cube is there, and we are nowhere getting v cube here. So we have to look ahead. So acceleration is equal to v dv by dx. V we have seen it is 2 alpha x plus beta to the power minus 1. What is d by dx of velocity? If you do the differentiation, what you will get is 2 alpha x plus beta minus 1 into, first of all, minus 2 alpha will be there on outside, then 2 alpha x plus beta minus 2. What you are getting is 2 alpha x plus beta minus 3 into 2 alpha, minus sign is outside. So if you look carefully, it is minus 2 alpha v cube. And they are asking about the retardation. So negative sign you can remove. So this will be the answer. Correct? Okay. Let's see next question. Try this one. This is also a easy but interesting one. You can keep things in centimeter because final answer is also given in centimeter. Or you can just convert because the speed is in meter per second. Okay. So I'm just reading the question. A particle describes a horizontal circle in a conical funnel whose inner surface is smooth. That means no friction is there. With speed, speed is also given. What is the height of plane of circle from the vertex of funnel? Correct. So if you can see that this situation is possible, D. Someone is saying D. Yeah, D is the correct answer. So let's see, the conical funnel is like this. and a particle is making a circular motion like this, in such a way that at this point, let's say we want to draw free body diagram, this will be mg, and the normal to the surface will be perpendicular, this one k. Now we need to see the angles also. Semi angle, you can just assume this to be theta, so this will be n cos theta. N cos theta, this will be n sine theta. You can see that n sine theta is balancing the weight, n cos theta is providing the centripetal acceleration. So you can write n sine theta is equal to mg, n cos theta is equal to mv square by r. Okay, now we can divide the two. What we are getting is tan theta is equal to mg by mv square by r, which is nothing but rg by v square, correct? But we want the height and we don't know the height. So what we can do is, let's say this is r and this is the height. If you see that here tan theta is nothing but r by h, correct? And this is also tan theta, this is also tan theta. You can equate this, r will get cancelled, h will be equal to v square by g, which is 0.5 whole square by 10, which is 0.025 meter. Multiply this by 100, so 2.5 centimeter is the answer. Correct. Let's see the next one. Okay. This is a bit easy question. You just need to find the frequency, then find omega. Then we know acceleration is omega r square. It is r is given as 30 centimeter, which is 0.3 meter. Frequency, that is frequency of revolution, is 1200 RPM, rotation per minute. So someone is saying B. Yeah, B is the correct one. Let's see the solution part. If you want to find in revolution per second, it will be 1200. Yeah, B is correct one. 1200 by 60, which is 20 revolution per second. We know angular frequency is 2 pi f, which is 2 pi into 20 radian per second, which is nothing but 40 pi radian per second. Acceleration, we know it is r omega square or omega square r, which is 0.3 into 40 pi whole square. It is 0.3 into 1600 pi square. We all know pi square is near about 10 only. So finally you will be getting 4740 meter per second square. So this is your answer. This was, I think, an easy one. Let's see the next one. C. Someone is saying C. No, I think something. Please check again. C is not the correct answer. Yeah, B is the correct one. I hope you guys are not seeing the Google and saying the answer. Okay, this. But if you are getting by yourself, it's good. So in the given question, Acceleration in x direction is 0. Okay, so we can say there is a constant velocity. Acceleration in y direction is, let's say, a, that is constant acceleration is there. Initial condition is also given at t equal to 0, x was 0, y was 0. So y will follow which equation? Because initial velocity is 0, so it is half at square. And x will follow because there is no acceleration, so only vx into t. And we know that y is equal to bx square. So simply we can put y as vxt whole square. So y is equal to b vx square t square, correct? And also this y is half at square. So half at square is b vx square t square. T square will get cancelled. Finally, vx, what you get is root a by 2b. This is the answer. Okay, let's see the next one. So in this question, what they are saying is a bullet fired into a fixed, that means the wooden block will not move, loses half of its velocity after penetrating 40 centimeter, correct? So let's say initially this is the first phase of wooden block and they have reached, let's say 40 centimeter. Here the velocity was u, here it is becoming u by 2. It comes to rest after penetrating a further distance. So it is going a further distance. Let's call it some s. Okay, this is, let's say, s1, this is s2. And here velocity is becoming 0. So from this condition, from first condition, what we can do is we can find the deceleration, which is, yeah, 40 by 3 is the correct answer. Yeah. So from this, we can find how much deceleration or retardation is being provided by the wooden block, correct? Then we'll apply it here and we'll get the answer. So in first case, you can say v square minus u square equal to 2as. Final velocity is u by 2 whole square minus u square equal to 2as was 40. Since we want to keep the answer in centimeters, so we can leave it like that. Acceleration is u minus 3u by 40 into 2, 80 into 4 is 320. So basically minus 3 is q square by 320 is the acceleration we are getting. Now we'll use this acceleration in the second part where in the final velocity is 0, that is v square minus u square, that is u by 2 whole square is equal to 2as. A is what? Minus sign will be there because it's a retarding force. 3u square by 320 multiplied by s2. U square will get cancelled. Both side minus sign will get cancelled. S2 you will be getting 40 by 3 centimeter. Okay, let's see the next one. Okay. Tell me this answer of this question quickly. This is easy one. Okay, I think now you should be telling the answer. So the question is saying E is equal to half mv square. Okay, so v square is equal to 2e by m. And since it is a uniform circular motion, we also know that centripetal acceleration is v square by r. And this is what we need to find. V square is what? 2e by m. So finally, what we are getting as 2e by mr. This will be the answer. Okay, correct. Let's see the
Can you
next.
give us like a little more time to solve question?
Yes, please come again.
So can you give us a little more time to solve questions?
Time. Okay, okay. Sorry. Basically, what I'm trying to do is I'm trying to touch maximum possible questions. But yeah, I'll try to give you some more time. Okay. Okay. Let's try this question. Someone is saying C. Yeah, C is the correct one. Okay, I think you are getting the answer. So let me just solve it. So the question is saying basically V equal to 2t is given, and they are asking radial and tangential acceleration. So we should be knowing what is tangential acceleration, which is nothing but dv by dt. So if you can see, it is nothing but 2 meter per second square. So it's easy, 2 meter per second square. And you can see that only one option is having 2 meter per second square. Okay, and that for tangential. So you need not to solve for first one also. But if you want to solve first one, that is also easy. AR is equal to V square by R. And it is given time equal to 3 seconds. So what is velocity when time is 3? It is 6 meter per second. So V square by R is 6 square by 0.3, which is 120 meter per second square. Okay. I hope this was a quick one. Okay, see this. Take your time, solve this question. You can see that the options are like far apart. So you can do the approximation also if you want to save some time. Okay. Let's just saying C. Yeah, C is the correct answer. I think you guys are getting the answer. So let's discuss the solution. So angle is 60 degrees. So horizontal velocity is u cos 60. U, which is given as 147. This is 1 by 2. So it is 3.5 meter per second. Uy is what? U sine 60, which is 147 into root 3 by 2. So 73.5 root 3 meter per second. Okay. Now, when the Vy and Vx component are, let's say they are saying that they are at 45 degree angle, That means what? After some time, like at any time, if the angle is 45 degrees, then Vx has to be equal to Vy. And what we can say is this won't change. Only this velocity can change due to acceleration because there is no acceleration along the x-axis. So whatever Vx, Ux was there, Vx will be same. So Vy we are getting as 73.5 meter per second. Okay, so from 73.5 root 3, we are reaching at 73.5. We know the acceleration, we know initial final velocity, we just need to find the time using v equal to u plus 80. So final velocity is what? 73.5. V equal to u is what? 73.5 root 3 minus a is 9.8 into t. Okay. 9.8 t is equal to 73.5 root 3 minus 1. T is equal to 73.5 by 9.8 root 3 minus 1. So it's near about 10. So 7.35 into 7.35 multiplied by 0.732. So it should be lesser than 7. So only option we are getting is 5.49. So 5.49 should be the answer. Correct? Okay. Let's see this one. Option B, you guys are saying B. Yeah, B is correct. Okay, so let's see the solution. So they are saying, let's say a balloon is there. Okay, and let's say some bucket kind of thing is there. Whole balloon is going with 5 meter per second, and we are throwing a stone at 10 meter per second. So with respect to ground, what you can see is the velocity with respect to ground of stone is 10 plus 5, that is 15 meter per second. Correct? Now we need to check that what they are saying, yeah, around 2 seconds, whether it is before reaching the maximum height or after. So for that, we have to look at the time at which the velocity will become zero, that is the highest point. So initial velocity, final velocity is 0, initial is 15 minus g 10. Why minus sign? Because direction of velocity and direction of gravity is in opposite direction, so we are taking negative sign here. So time it will take to reach the maximum height for a ball with respect to ground is 1.5 second, but they are asking 2 seconds. That means it is going like this and it is stopped here, and it will take around 1.5 second. So what time is left? 0.5. So at this point, initial velocity is 0. So final velocity will be what? 0 plus g is acting in the direction of displacement. So 10 into time left was 0.5. So it is 5 meter per second. This will be the answer. Okay, let's see the next one. See this question. Okay, someone saying D. No, D is not the answer. A, yeah, A is the answer. Yeah, and this is also easy question only because if you look, this is a displacement time graph slope. So slope is giving you the velocity. So V1 is tan 30 degree. Tan 30 is 1 by root 3. V2 is tan 45 degree, which is 1. So the ratio is 1 is to root 3. This will be the answer. I think this was the easy. Okay, see this question. A. Okay. Yeah, answer should be A only because it is a relation of S and T, and we know one relation which is UT plus half AT square. Let's assume that at initial velocity U is 0, so S is half AT square. At constant acceleration, S is directly proportional to T square. So it is a graph for what? It is graph for opening upward parabola, which is this one. Okay, I hope you got this answer also. Let's see, I think this is the last question from kinematics. Are you able to see the question properly? Because,
No, sir. Right, now we can.
okay. B. Yeah, B is correct one. Yeah, B is, I think all of you got it correct only because it's very clear that at any instant, if you are saying it's a one dimension, we cannot have two directions. So this, the first one is wrong. This is wrong. This is wrong. And the velocity, speed cannot be negative. So this is wrong. So this is one is the correct. Okay, now we have to start laws of motion, friction, and circular motion. So collectively we call it dynamics. And I don't think so that some theoretical background is required here because we'll be using what we already know from since class 10th, a little bit extra. But Newton first law, second law, third law. Newton second law is important, which is F net is dp by dt. This formula, change of momentum. Correct. So I think we should jump straight forward to the questions of Newton laws of motion, NLM. Okay, let's see the questions one by one. Okay, try this one. E is the correct answer, 7 by 8 F. Okay, let's see the solution. So in the given question, let's say our horizontal plane is there, a block is there of mass m, and a rope is there, and the mass of rope is also there. So tension at each and every point will be different, basically, because there is a mass involved also. And the question is saying one end of the rope uh, of mass m by 3 is fixed to block, which is pulled in a direction, in a horizontal direction by F at the other end. So basically they are pulling at the other end with some force F. The tension at the middle of the rope. Let's say they are asking what is the tension at this point. So first of all, we should be knowing what is the acceleration of overall system. Okay, then we can pinpoint the particular point and find that which tension force is responsible for that acceleration. So total mass is what? Total mass is mass of block plus mass of rope, which is 4m by 3. And if you know the total mass, so acceleration of system will be what? It should be force by m. Here force is F, but the mass of system is 4m by 3, which is 3F by 4m. Now, tension at the middle must pull the block M, correct? So if let's say this is the tension, so this tension must be pulling the block, this M block, and whatever this mass will be, since it is a half, so M by 6 plus M, correct? So mass being pulled by that tension, okay, because this is what we need to find, is how much? M plus M by 6, which is 7m by 6. And how, which is pulling this mass? Tension T is pulling the mass with acceleration A. A we know it is 3F by 4m. But this M is what? This. So you can say 7m by 6 into 3F by 4m. So M will get cancelled and 3 is 2. So 7 by 8 F is the answer. I hope you understood this question. Let's see the next one. Okay. Sorry. A. Yeah, A should be the correct answer. The question is saying an object of mass 5 kg is attached to a hook of a spring balance, and the balance is suspended vertically from a roof of a lift. Okay. The reading of the spring balance when lift is going up with acceleration. If lift is going up, correct, then overall effective gravity will be more. So effective gravity, you can say it is G dash is nothing but G plus A. So 10 plus 0.25, which is 10.25 meter per second square. Now we know the reading is nothing but mass into acceleration, that is the weight. So the reading which you will be getting is m into G dash, which is 5 into 10.25, which is 51.25 Newton. Okay, so this will be the correct answer. Let's see the next question. Yeah, this one. Okay, so what should be the concept here? You guys are getting E. Yeah, E is the correct answer. So the concept is area under FT graph is change of momentum. Change in momentum. Okay, that is MVF minus VI is the area under the graph. And they are saying initially it is at rest, so this will be 0. So mass into final velocity is nothing but the area. This area is how much? 10 into 220 divided by 2. That is, this is 10 and this will be 20. 10 plus 20, this is 30. And this is 20 into 480 divided to 40. Okay, so overall area we are getting is 100 and mass is 2 kg. So V is equal to 100 by 2, which is 50. So this is the correct answer. Okay, I hope you understood this one. Let's see the next. Okay, are you able to see the question properly? Yeah, solve this. D. Yeah, correct answer is D. Actually, in this question, the springs are in series. So whatever tension in spring Y, that same tension will be in spring X. Since same tension will be there, then they will measure the same mass. Okay, so basically this will be the correct answer. Okay, see this one. This one is easy. I think you can give answer quickly. This is D. Yeah, D is the correct answer. So basically they are saying that P is the force which is pulling the two mass, that is mass m and small m. So overall acceleration you will get is A is equal to P by m plus m. So whole system is moving with this acceleration. Now the force that must be acting on block is what? The mass of the block and the acceleration, and the whole system is moving with acceleration A. So mp by m plus m. So D will be the correct answer. Okay, see this question. Just conserve the momentum. No, I don't think so. C is the correct answer. So a truck is moving on a frictionless surface with uniform velocity 10 meter per second. A leak occurs. Okay, a leak occurs in the water tank of truck. See, in this question, leak word is there, so you can assume that the water must not be uh, coming out with certain velocity. It's just sipping to the ground. So no momentum is generated or destroyed there. So you can say initial momentum of a system is 100 kg is truck, 100 kg is the water. So initial mass is 200 and the whole mass is moving with 10 meter per second. Finally, they are saying it is leaking at the rate of 2 kg per second. So after 50 seconds, how many kgs must have moved out? It should be 100 kg. So what left afterwards is 100. So since there is no external force, so you can say final velocity is something UF. UF is 20 meter per second. You understood this one? Because I was getting the mixed answer for this question.
Yes, sir, yes.
Okay. Okay. See this question. B. Yeah, B is the correct answer. So a gun fires bullet each of mass 1 gram with velocity 10 meter per second, exerting a constant force of 5 gram weight. Constant force F means what? 5 gram means 5 into 10 to the power minus 3 into G. That is 10 gram weight is generally considered as mg. Whatever mass multiplied by G is will be the force you'll be getting. So 0.05 Newton. Momentum per bullet is how much? Momentum per bullet is 0.1 gram, so 0.001 into velocity is 10, so 10, so 0.01 kg meter per second. We know the total force must, all the change in momentum must be creating the total force, which is F equal to NP. So N is equal to F by P. It should be 5. Correct? Let's see the next one. Okay, solve this question. Yeah, this one is B. Because mass mass is 3.5 into 10 power 4 kg. So mg force will be 3.5 into 10 power 5 Newton. Now, if you want to accelerate that mass with 10 meter per second square upward, first of all, you have to take care of the weight. And then you have to provide extra force so that it will move with 10 meter per second square acceleration. So basically it's m into g plus a. Acceleration is 10, it is 10. So 3.5 into 10 to the power 4 into 20. So I think this will be the correct answer. 7. Okay. I hope this question does not need any calculation. You have understood this one. Okay. Solve this question. Okay. Let's see this question.
So can you give a minute?
Okay. No problem.
So never mind, I'm not getting any. You can solve it.
Okay. See, basically, here friction is there and the block is moving. So initially, let's say the impulse is acted in this direction. So it will start moving with certain initial velocity. Then it will come at rest after traveling 0.06 meter. So all along the path, force is acting and all. So and speed is also not constant. So we have to use work energy theorem here. Okay, that means let's say initial kinetic energy will be there because some due to impulse some velocity will be there. So initial kinetic energy is m half mv square. Finally, when it has reached this position, all along the path, what is the work done by the other forces? For the spring force, it is half kx square. Work done by the friction force is mu mg x. So all this kinetic energy is utilized as potential energy and some part of it is lost in friction uh, dissipation. Correct? Now, mass is given to you as 0.18, so half it's 0.09 v square. K is 2, so simply 0.6 whole square, that is 0. Uh, wait, 0.06. So 0.0036 will be there because k is 2, half into 2 is cancelled, only left is x square, which is this. Plus mu is given to you as 0.1 into 0.18 is m into 10 is g into x is 0.06. Correct? So what we are getting is 0.09 v square as 0.0036 plus 0.18 into 6, 144. So 0. Overall, we'll be getting, sorry, yeah. So 18 into 6 into 10 to the power minus 1 minus 2 minus 2. So it is minus 5 and 18 6 is how much? 868 616108. So it is 0.00108. Correct? If you add the 2, it is 3108 plus 36 144. 0.09 v square is 0.0144. So basically what we are getting is v square as 9, it is by 16 into 9, yeah, because 160. So it is 0.16. Basically v is 0.4 meter per second. Correct? Now they are asking v in terms of n by 10, so 4 by 10. So this is 4 by 10, so 4 is the answer. A bit calculative, but simple. Okay, see this one. A, yeah, A is the correct answer. Basically, here we need to look at the limiting friction first. So overall, this as a system is 10 kg, and mu between B and the floor is 0.5. Correct? So 10 kg into 10 is the Newton weight. In multiplied by 0.5 is nothing but 50 Newton. You can see the limiting friction itself is greater than the applied force. So the whole system will not move. So there will be no relative motion between A and B. So there is no force of friction. So A is the correct answer. Any doubt in this? Okay, let's see the next question. Try this one. Okay, anyone getting the answer? A. Yeah, A is the correct answer. So they are asking the distance traveled by the center of mass in 2 seconds. Okay, let's see the solution first. First of all, let's see the acceleration of the whole system. So there will be one tension force downward is 20 Newton force, correct? And let's assume the whole system is going downward with acceleration A. So this has to be also A. This is 10 Newton force. This is the same tension force T. So 20 minus T for this one is equal to 2A. T minus 10 is equal to A. You can see that if you add the two equation, T will get cancelled and it is 20 minus 10, that is 10. It is equal to 3A. A is acceleration of system is 10 by 3 meter per second square. Now we need to find the acceleration of center of mass. Okay, so we know the formula of acceleration of center of mass. Let's say if there are multiple objects having some acceleration, you can use m1a, a1 plus m2, a2 like that. So m2a plus m1. Here it will be minus a because the sense of acceleration is opposite for the both the blocks. So m1 by plus m2. It is 2 minus 1 into 10 by 3 divided by 3. So it is 10 by 9 meter per second square. So acceleration of center of mass is this. Now initial velocity must be 0 because the system is at rest initially. So the distance traveled by center of mass is nothing but half into A center of mass into T square. So it is half into 10 by 9 into time is given as 2 seconds. So 2 square is 4. So it is 2. So 20 by 9 meter is the answer. So in this question, concept of center of mass was also there. Okay. Basically, by finding the acceleration of system, we know the acceleration of both blocks. Now we know now we don't exactly know what is the center of mass or acceleration center of mass. So we just need to use the formula. No need to think extra here. Okay. This part is clear. Okay. Let's move ahead. See this question. Table surface is rough where a metal chain, uniform metal chain is hanging. One end of it hang down over the edge of the table when one third of its length hangs over the edge. The chain starts sliding. The coefficient of static friction. Okay. D. Someone is saying D. No, please check your answer. So in the question, they are saying, let's say a table is there and a chain is hanged like this. Okay, this is L by 3. This is 2L by 3. Okay. Yeah, E is the correct answer. You see the solution. So downward pulling force in this case, downward pulling force due to this must be balanced by the friction force, correct? So you can say that mu into normal force is equal to, that is the friction force, that is the pulling force, which is what? 1/3 of mg. So mu is 1/3 of mg, whereas normal force is 2/3 of mg. So 1/3 and 1/3 is get cancelled. This is cancelled. 1/2 is the answer. Okay, let's see this one. Answer should be A. Yeah, answer should be A. So basically, what is happening here is mu mg is the friction force that must be acting. Okay. If you remove the mass, what you will get? Deaccelerating, or sorry, deacceleration, which is mu into g. Okay. So we know the acceleration. So we can use V equal to U plus AT formula. Since V is 0, U is given as V only, and this is deacceleration, so minus mu g T. So you can see T is equal to V by mu g. This is the answer. Okay, I hope you understood this one. Okay, see this question. Here, I think in option there is something wrong. Acceleration of each block. Yeah, no, it's correct. It's actually easy one. So total mass, if you look at, it is 4 plus 2 plus 1, that is 7 kg. Okay, and acceleration will be total mass by m, 28 by 7, that is 4 meter per second square. So this will be the answer. I think this one was very easy. Okay, see this one. So what you are saying? A. Yeah, A is the correct answer. Okay, so first of all, if you want to check whether the block will move or not, we have to look for limiting friction, that is mu s into mg. Mu s is given as 0.5, m is 2, so 2 into 10. So basically what you are getting is 10 Newton. So limiting force is 10 Newton. So that means the block must not be moving because it is less than the limiting force. But since we know that the friction is a self-adjusting force and it will adjust or increase the friction force till it has reached the limiting one. So it is also 5 Newton. Because if the system is at rest, so friction has to be 5 Newton. Okay, see this one.
So we can't see the whole question. Okay, now it's there. Sorry.
Okay, okay. Yeah, actually this question is easy as I can see the answers coming up. So basically we know mu is tan of theta, angle of inclination, tan 60 is root 3. Root 3 is 1.732. So this was easy question. So 1.732 is the answer. And you can see that these are the types of questions they will be asking in K-CET. So if you are just you can just brush up the basics and solve some decent questions, you are good to go for K-CET. Okay, see this one. I think this is the last question for today's session. We have done around 34 questions today, including this one. So in this question, 60 degree is with the vertical. So this will be 30 degree, correct? And what you are getting? You are getting A. Yeah, A is the correct answer. Okay. So the axis, let's say at certain height, a block slides down and this height be h, correct? If this is h, then what should be this length? If you look at sine theta, that is sine 30, it should be h by, let's say this distance is d. So h is nothing but d sine 30. So d by 2, correct? So this distance d, if you say d is h by sine 30, so d is nothing but 2h. So it is equal to 2h, correct? Now, in first case, we are sliding it like this. And in second case, at the same level, we are dropping it like this. We just need to find the time it will take. Okay. So what is acceleration in this direction? It is g sine 30 degree, which is basically g by 2. But in this direction, acceleration is g. And distance also we have calculated 2h. Now, let's find what is time t1. T1 is root under what is acceleration, how much time it will take to go down. Distance we know, initial velocity is 0, then acceleration we know. Clear? So T1, if you look at it in terms of h, it is 8h by g. T2 you must be getting as 2h by g, so that T1 by T2 is root 8 by root 2, which is 4, that is root 4, that is 2. So T1 is to T2 is 1 is to 2. Okay. I hope you got the answers And I think this is the last one. Yeah, this is the last question, and we are on time. Okay, so I hope you have understood this one, but the purpose of discussing these problems are just to help you to start so that you can solve some more questions. So what your homework should be is try to solve a decent amount of questions, or you can just solve PYQs of K-CET from chapter Kinematics and Newton laws of motion. Because if you are going with us, then it will help you a lot to complete the course alongside. Okay, so I hope you like this session. We'll meet in next session. Okay, thank you everyone.
Thank you, sir.